circle, our table from our unit circle. Our x is really theta, it's the angle that we plug in, and our y is just the parent function sine of x. From our unit circle, we have 0 all the way to 2 pi, so we're just going to get the quadrantal angles right now. 0, pi over 2. Sorry, it's going to be in radians, yep. Pi over 2, pi, 3 pi over 2, and 2 pi. We also have to do this for, and sometimes 2 periods forward, so we'd actually go to 4 pi. But actually, we're mostly going to do 2 periods, 1 positive, 1 negative, so we'll also go to negative 2 pi. At 0, the value of sine right from our unit circle is 0. At pi over 2, it's 1. Then back to 0, then down to negative 1, then back to 0. So the parent function for sine is sinusoidal, in that it has a wave that goes back and forth. It starts at 0. At pi over 2, it goes up to, I'll make this 1, and this negative 1. Goes up to 1, comes back down to 0 at pi radians, then down to negative 1 at 3 pi over 2, and back up to 0 at 2 pi. So it's oscillating back and forth between 1 and negative 1 as we go around the unit circle. And if I continue going around the unit circle, doing more and more rotations or revolutions. Hello? Good, how are you? I'll send her down, thanks. Anna, you're heading out. If I kept going, then it would continue this pattern as it goes into the next circle also, as we get to higher and higher radians. All right, but now we have to go the other direction. So normally I make a table for that too. Looking at our unit circle. So I pick up everything, guys. Your conversation that you're having right now. If you have a question to ask, some of you weren't here last week, so you don't have a clue what's going on. We're just grabbing the numbers off the unit circle. So I have to go from 0 to negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Which means I'm just going in 90-degree increments in the reverse direction from our initial ray. So I go back, 3 pi over 2 is negative pi over 2. Those are the same terminal ray. So that's going to be negative 1. Negative pi is the same coterminal value as pi, so that's 0. Negative 3 pi over 2 going backwards on the circle 3/4 of the way around is the same as going forwards, pi over 2. So that's going to be 1. And then we come back to 2 pi, or 0 radians, same in terms of coterminal, we get 0 again. So now this one going back here goes down, then back to 0, then up, then back to 0. So this continues. Any questions on those? All right, so that's our parent function for sine. We need to talk a little bit about the domain of sine. Any guesses on what the domain is?
Infinity.
Yep, negative infinity, positive infinity. It has an infinite domain. It's a continuous function with no interruptions.
Is that going to be all the time?
For any sine function, yes. Unless, well, there's certain things we can do to it to change it, but for the sine functions we're looking at, yes. Here's what I wanted. Don't want to miss anything. So in terms of continuity, it is a continuous function. It's extrema. It does have extrema. What's the height of those extrema, at least for the parent function? 1 and negative 1. So one of those extrema occurs every pi over 2, right? Pi over 2, and then 2 pi away from there it would repeat. or 2 pi away from it back here, it would repeat. So it's going to be pi over 2 plus 2 pi n, that's the x coordinate. Because every time you get to that point on the unit circle, it's 1, no matter how many revolutions I do, and the height is 1. And then for the negative, it's at 3 pi over 2. And anytime I hit that value going around, revolving around the circle, so plus 2 pi n, I got a comma. Yeah. But then the y coordinate is -1. So it's our maximum and minimum points, or our relative max and relative min. Our end behavior. Well, as we continue, is it going to approach infinity? What's it going to keep doing? Just oscillating back and forth. It's not really going to approach 1 or approach -1 or even 0. It's just going to keep oscillating. So it's not applicable. Unlike our functions that have horizontal asymptotes where it approaches that value over time, or where it shoots up infinitely or down infinitely, this one's just going to keep oscillating. Our range for this, -1 to 1, brackets. There is symmetry. That symmetry is called, can't think of the word, we'll get to it. It has a specific name, but the symmetry is at, symmetry in terms of even versus odd. If it's even, it's reflected across the y-axis. Is that going to be this case? No. This one would actually have rotational symmetry. If you took this graph and rotated it, you get the other side. So it is going to be an odd function in that it has rotational symmetry with the origin. Yes? Leah? Right. Thank you. So that's odd. Oscillation, it oscillates from 1 to -1. Amplitude, period, frequency, and sinusoidal. It is a sinusoidal function. There's only one other trig function that is, and that's cosine, as you saw in our exploration. Cosecant, secant, and tangent have vertical asymptotes. These two functions do not. When we go to write equations, or when we go to graph them and stuff has happened to the parent function, we're going to have to pay attention to the amplitude, period, and frequency. The amplitude for this one is 1. And it's actually the lead coefficient on the function. There is no lead coefficient. It's hidden in multiplication. It's 1. The period, how long does it take to repeat this process, or to begin repeating this process? Well, that would be from here to here. 2 pi is the period. 2 pi is going to be the period for our parent function for both sine and cosine. And then our frequency is just the reciprocal of the period. It's 1 over 2 pi. So it's, trying to think of how to explain it. I'll have to look it up for the formal definition. I have it written down over here. 1 second. 4.4. I don't want to do something. The number of cycles the function completes in 1 unit interval. It's the reciprocal of the period. Definitions of amplitude, period, and frequency. Period is how long it takes. Amplitude is really how high, or the height of the oscillation. And one of them is going to be in a positive direction. One's going to be in the height of the oscillation.
I don't think it spells height.
I wrote how high and then I changed it. Height of the oscillation. The period is how long it takes to complete 1 cycle, or how many radians. frequency is I read the definition, but I need to dissect it more because I don't have it written down on my new sheet. It's basically going to be 1 over the period. Anybody have a better definition off the top of their head? Some of you are in physics, right? All right, we'll come back to that. For now, you just need to find it. It's the reciprocal of the period. Yeah, there's a formal, a technical definition for what it is you're actually looking at, but when I look at it in the book, it doesn't make sense directly, so I need to look at it again, and I'll be able to explain it better later. Sinusoidal function is one that oscillates back and forth. It's kind of in there in terms of how you use these things to graph, but not an actual vocab. Recall parent functions for transformations. Did you have a question? Oscillate means to go back and forth, like this. And there's only 2 functions in our trig functions that do this, and they're sine and cosine.
But on the top, oscillation is 1 to -1.
And so it's oscillating from 1 to -1. Or between those 2 heights. Recall the parent functions. You guys did this in Algebra 2. We're going to change it a little bit. Anyway, this should look somewhat familiar, right?
Yeah.
What do H and K do?
K is like the amount.
K tells you how it does what? How the function shifts up and down, vertical translation. And it's exactly as we see it. We're going to change these letters a little bit as we do sine and cosine, or as we do our trig functions. But basically, K is, as you see it, it's either, it's a translation, up if it's positive, or down if it's negative, K units. H is a little bit different. You see that minus H. So if I saw a plus 5 in there, what would actually happen? It'd go left 5. It's counterintuitive. Let's look at A though. A does what? Does anyone remember?
Like stretch.
Vertical stretches and compressions. And there's one other thing. So as long as A is bigger than 1, says the absolute value of A, because it could be negative, then it's going to be a vertical stretch. If it's less than 1 but greater than 0, when I look at the absolute value of A, which means it's a fraction less than 1, not a fraction like 3/2, which is bigger than 1, then it's a vertical compression of the graph. There's one other thing that A does. If A is negative, what happens to the graph?
Flips vertically.
It flips over the x, it's a reflection over the x-axis. When A is negative, it is a reflection over the x-axis. Now it's a little different for B and H. Those are stuff, B and H are things that happen horizontally, but they're actually counterintuitive. So when I see, well, the negative isn't. If B is negative, then it means that there's a reflection across the y-axis. But there's something else B does. If I see that B is greater than 1, then what is it actually? A horizontal compression of 1 over B. And if B is less than 1 but greater than 0, then it's a horizontal stretch. It's counterintuitive. You see that fraction and think it's going to be a compression, but it's actually a stretch of the reciprocal value. As far as H is concerned, when I see that minus H, we know that that's also counterintuitive. If there's a minus sign in front of it, then it's then it goes right H units. And if there's a plus sign in front of it, then it goes left h units. Now we're going to approach this the same way when we do our trig functions, but instead of calling them h and k, the book calls them c and d. So instead of looking like this, our trig functions, their transformations will look like this according to the book. But C is the same as H, D is the same as K. Now there's something that you didn't have to deal with in your other functions, most likely in Algebra 2 they didn't deal with it, but that we will have to deal with here, and it's right here. Are they always going to give me the function looking like that? No. More likely it's going to look like this. And if I want it to look like what I have above,
Together B.
then I'm going to have to do what? One of the F words of mathematics. Factor. Factor out B, and then I'll know what this actual number is. There's also a formula. Some of you will just use the formula when we get to translating it right and left. It's called a phase shift. There's a formula. We'll get to that today. So let's take a look at the parent function of cosine real quick. And then we can do some transformations with these. The parent function for cosine, we're going to have two tables, one going in a positive direction again, one going in a negative direction. Why is it doing this? I don't know. And again, normally, some of you, when you did your exploration, especially when we got to secant and cosecant, found out that you wanted 30-degree increments, pi over 6. Even though some of them couldn't be plotted, it gave you a more accurate graph. But for just graphing the parent function of these real quickly, we're going to look at just the quadrantal angles. So we have 0. No, I don't want that. 0, pi over 2, pi, or sorry, 3 pi over 2, and 2 pi. Then I have to go in a negative direction. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And start at the negatives and work your way to the positives if you want. So for cosine, though, this is 1. And then not negative 1, positive 1. And then it goes up to 0, and then to negative 1, to 0, to positive 1. So I'm going to plot that first. Make this my 1 since I don't have anything bigger. So we've got 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi 1. So it's also oscillating like sine, but instead of starting at 0, 0, it starts at 0, 1. It starts at a height of 1 instead of a height of 0. And then at negative pi over 2, so going backwards on the unit circle, we have 0. Negative pi is equivalent to pi. Negative 3 pi over 2 is equivalent to pi over 2. And negative 2 pi and 0 are the same. So I have 0, negative 1, 0, 1. And it keeps going. It's going to curve down. It's not going to keep shooting up. It's going to curve back down from that point. So that's cosine. That's actually 2 periods of it graphed. There's a positive period of it graphed and one negative period going from 0 to 2 pi and from 0 to negative 2 pi. The domain is, once again, negative infinity to infinity because we have nothing restricting this function. It is a continuous function. Its extrema, again, are 1 and negative 1 in terms of the height, except it's happening at different places. For sine, it happened at pi over 2, and for cosine, the 1 is happening at 0. And then every rotation around from that location, so 0 plus 2 pi n, obviously where n is an element of the integers. And then the height is 1. And it's negative 1 every time it touches pi, or something coterminal with pi. Pi and negative pi are 2 pi units away. So that would be pi plus 2 pi n, comma negative 1. In terms of n behavior, it just keeps oscillating, so it's not applicable. It is sinusoidal. Since it keeps oscillating, the oscillation goes from 1 to negative 1. The range is also from negative 1 to 1. What about symmetry for this one? Would this have even or odd symmetry? So odd is rotational, right? If you rotate it 180 degrees, or if you rotate it from 0, 0, you get the same thing. That happened for sine. Even is where it would be.
Yeah, can you explain that a little bit?
So from first semester, odd symmetry is when you have rotational symmetry. Like if I rotate this 180 degrees, it would look exactly the same. Even was when it's reflected over the y-axis, like a parabola that the vertex is on the axis. I would get the exact same graph back. So which one would this be?
Even.
Even. As if I reflect right down the y-axis, that's not an asymptote, I'm just drawing an axis of reflection, it would fold right onto itself. So for the parent function anyhow, it's not going to be true if I translate it left or right. It has even symmetry, it is symmetric with the y-axis. The other one is, when it's rotational, it's said to be symmetric with the origin. The amplitude, the height, when you're going from 0 up or down, is 1. The period to complete one full oscillation is 2 pi units, just like it was for sine, 2 pi radians. The frequency is the reciprocal of this, so 1 over 2 pi.
Wait, what is
Sinusoidal means it's a function that oscillates back and forth.
Yes.
So we have a key summary of some of the things that we've written down. This is straight out of your book, but you have them written down. You've seen them on the graph. You should be familiar with them. We're going to have a formula. Oh, that's where I meant to define it. Go back to the first page. I forgot to define this. To calculate the period, it's always going to be 2 pi over b. So if there is a horizontal stretch or horizontal compression, obviously it's going to impact how many radians we need to complete the cycle. And then the frequency will be the reciprocal of that, b over 2 pi. Find the amplitude and period, sketch two periods, one positive, one negative, and describe the two functions. For this graph, we should be okay because I scaled it for you already. Sometimes it's not scaled for you. A lot of times it won't be. There's one on here that we're going to do today where we're going to have to rescale it, though it doesn't work. So regular sine, we can graph easily. We know that that starts at 0, 0, and we can make a table if we want for sine, and then change that table to get 5 times sine of 2x. First off, we expect with the 5 there to be a vertical stretch, and with the 2 there to be a horizontal compression. So our period should actually be shorter. So sine, I'm actually going to make my table this way for this function of sine of x. 0, pi over 2, pi, 3 pi over 2, 2 pi. We'll just do the positive for now. And that was 0, 1, 0, negative 1, 0. That's sine. I should probably, before I do this, before I actually plot, I should make my other table. But I know it's going to fit, or I'll be able to make it fit on here, so we're going to leave this for now. Or we're just going to plot it for now, even though technically I might have to rescale this based on. So there's one positive period, and I also know for the negative one, I'm just going to go in the reverse order. Nope, that's not right. Or you can make the table for that. So there's sine. That's going to be our f of x. Now, what does this 2 represent? A horizontal compression of 1/2. So to every value that of my x coordinates, I'm going to multiply it by 1/2 or divide by 2. So for my new x coordinates, for g of x, that stays 0, but this becomes pi over 4 instead of pi over 2. This becomes pi over 2. This becomes 3 pi over 4. This becomes 2 pi over 2 is just pi. So my period is half of what it was before. Before it was 2 pi. Now it's a horizontal compression of 1/2, so the period is half of what it was before. So that's what happened to my x coordinate, but my y coordinate also changed because the 5 is a vertical stretch of 5. So my new y coordinate, 0 times 5, okay, that's easy. This will be 5, 0, negative 5, 0. Since we didn't shift the graph up or down, I don't have to worry about, adding or subtracting anything yet. We're just looking at vertical and horizontal stretches and compressions. So I'm going to plot 0, 0. And then at pi over 4, which is here, I actually need to plot 5. 1, 2, 3, 4, 5. At pi over 2, it's back down to 0. At 3 pi over 4, which is halfway between pi over 2 and pi, I'm at negative 5. And then at pi, I'm at 0. So I can physically see the vertical stretch and the horizontal compression because the one positive period is now half as long in terms of the graph, or half as long in terms of the x-axis. And then I'm just going to repeat this on the other side. At negative pi over 2, at negative pi over 4, sorry, it's going to be down at negative 5 because it was up at positive 5 for pi over 4. And then it's going to come back up to 0. At 3 pi over 4, it's going to get 5. And then back down to 0 at negative pi. And if you're not comfortable with that, you can make a table for those values as well. When we start doing phase shifts, which is left and right, or translations up and down, then we will actually want to make sure we do it on the table so we don't make any mistakes with it. Any questions on how to get the horizontal or vertical stretches and compressions? All right, letter B. What happens to cosine for letter B?
Flip over the x-axis.
Yep, it's going to be a reflection over the x-axis. And with that, it'll also be a vertical stretch of 2. And then what about that x over 3? What does that mean?
Horizontal stretch.
Horizontal stretch of 3. So we have a slight problem with this in that it's not scaled right. Okay? If it's going to be a horizontal stretch of 3, instead of ending at 2 pi, it's actually going to end at what? 6 pi. I'm going to multiply all the x coordinates I would have had by 6. So this will be 6 pi. This would be 18 over 2. Wait, no. Times 6.
Times 3.
Yeah. Times 3, sorry. Times 3 would be 9 pi over 2. This one's going to be 3 pi. This one's going to be 3 pi over 2. So that rescales our axis. So now we're going to go ahead and graph sine, but that's kind of messy. I probably should have left blanks there to completely rescale it.
Do
Yes?
you always do the horizontal stuff first before you do anything?
Yes, because it's going to change our x-axis.
Is that like that?
We also need to know that, hey, it's got a vertical stretch of 2, so the highest I need to go, unless it's a translation up or down, is from 2 to negative 2 on the graph. What did you ask, Saber?
What is that black dot at the end? Where it was
Black dot.
That's 6.
That's a 6. That became 6 pi. Technically, we should actually draw our own graph and scale this better so we could actually see 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6, because then I can actually get the values in between them. So I think we're actually, this is the one I said I needed to fix and rescale, and unfortunately I'd already printed it. So this is 1.5 pi. I don't like the way this is scaled at all.
Yeah, I think we should just.
You guys are gonna have to be able to scale it though. So what I'm gonna do instead is I'm gonna make this 1, 2, 3, 4, 5, 6, 7, 8. We'll make this 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. I wish I had more things because I would do half values between them. We're gonna have to put tick marks between them. So with cosine, it starts at 1, right? I'm gonna make this 1 and this -1, this 2 and this -2. With cosine, it starts at 1, and then at pi over 2, if this is pi, pi over 2 is right here, goes to 0. And then it goes to -1 at pi. At 3 pi over 2, which is halfway between those, it comes back up to 0. And then at 2 pi, it's back to 1. So there's one positive period of regular cosine, just from the table that we have on the front page. I'm actually going to write this table up here. So we had 0, pi over 2, pi, 3 pi over 2, 2 pi. Cosine of x was 1, 0, -1, 0, 1. But now, I have to multiply the x's by 3. So my x's are actually 0, 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. And my y's I have to multiply by -2, so they become -2, 0, +2, 0, -2. 9 halves is like 4.5. 3 halves is 1.5. So when I do this, I have 0, -2, and then I have to go to 1.5 pi to get the 3 halves, and that's 0. 3 pi over 2, or 3 pi is going to be +2. 9 pi over 2, which is 4.5 pi, roughly. No, exactly, actually, is 0 again. And then 6 pi is -2. There's 1, 2, 3, 4, 5, 6. So we can see the reflection across the axis. We can see, I don't know what happened with my black graph. It must have gotten erased somehow. Oh no, it's just hiding underneath it, right? Oh no, that is it. It stopped right there. Because the other one's been stretched. That's all there is to that. Okay, we can see the reflection. Now we should continue this table in the negative direction also. Does anybody need to see that? You guys good with that? The negative? All right, our last example of graphing, and then we talk briefly about how to write functions if I'm given information. And so cosine, same thing. What's going to happen here though? Vertical compression of 1/5 and a reflection over the x-axis. So I probably don't want to make this 1, right? Because if I do, then I have to figure out what 1/5 is. Where should I put the 1 instead? At the top. At the 5. If this is 1, then this would be 1/5. This would be -1/5. This will be -1. So now we've got our y-axis scaled correctly. For x, there's going to be a horizontal compression of 1/3. So I could actually leave these here for now if I want to, but I want to make sure that I'm going to be able to fit the 1/3. I might rescale it, because that's going to be tricky to figure out. We'll make our table first. So cosine, we have the same stinking function again. In terms of x and y, we have 0, pi over 2, pi, 3 pi over 2, 2 pi. We have 1, 0, -1, 0, 1. Now, our x coordinates have been multiplied by 1/3. So they are now 0, pi over 6, which is why it might be helpful to graph this by thirds, increments of thirds if we had more things, or if we were going to scale it and graph ourselves. Pi over 6, pi over 3, pi over 2, pi, right? If we graphed by thirds, we'd see it a lot more clearer. And so then this one's going to be 1/3, so pi over 3. This will be 3 pi over 6, which is pi over 2, right?
Is that how it would be?
Yeah, it's pi over 3. And then this one's going to be 2 pi over 3. Okay. So we're not even going to get to pi in terms of those. So what we need to do, if we're going to leave our graph like this, we need to split it into thirds. Like, hey, there's pi over 6, pi over 3, pi over 2. There's 2 pi over 3 and 5 pi over 6 before getting to pi. So by splitting this graph into thirds, we'll be able to plot that a little more accurately. So I'm actually going to start by plotting the bottom one, but I want to make sure I have the right y coordinates first, which that's easy. That's going to be it's negative 1/5, 0, positive 1/5, 0, negative 1/5, because I had a negative. So at 0, I have negative 1/5. At pi over 6, I go to 0. At pi over 3, I go to 1/5. At pi over 2, I go back to 0. At 2 pi over 3, I go back down to negative 1/5. So there is g of x. And I haven't done the negative period yet. I would extend the table to do that. And for f of x, I've got 1, 0, negative 1, 0, 1. So I can see the horizontal compression and the vertical compression and the reflection in the graph. Any questions on that? I only did one positive period, so you want to make sure to make the table to do the negative period also. Why isn't this working? Of course it's not working. All right, writing a function. Write a sine function that can be used to model behavior of a sinusoidal wave. You're actually going to be given some graphs later, not today, maybe a couple today, but mostly in numbers, where you can figure out the period from the graph and the amplitude from the height, and you're going to write the equation of it. So here's the frequency. Something to remember about the frequency, it is the reciprocal of the period. So the period is pi over 5. And the amplitude is 3. That's the value of A. Because for sine and cosine, right, if there was no letter A there, it was a 1. If there was no other number there, and then it went oscillating between 1 and negative 1. In the problem above, you see that the coefficient is 1/5. So the amplitude is 1/5. Okay. So we know it's going to be y equals 3 sine of something. We have to figure out what. Okay. Well, there's a relationship between how we calculate the period. The period is calculated by 2 pi over b. Well, I already know the period is pi over 5. So I can use these two ratios to set up a proportion and figure out what b is. If 2 pi over b, in this case, is equivalent to pi over 5, I'm just going to cross multiply. 10 pi equals b pi. Guess what b is? 10. So 10x. There's no c or d, h or k, because it didn't say that there was any phase shift, which is left and right, or vertical translation. We're not going to worry about that right now. We're just worried about period and amplitude. So remembering that frequency is the reciprocal of the period, we can figure out what the period is. We can set up a proportion to figure out the value of b and plug it into our function. Try this for letter b. right? 6 sine of something. What'd you guys get for B? Anybody have an answer for B? What'd you- 4/3 is correct. So here's the period, 3 pi over 2, and we know that that's equal to 2 pi over b. So you cross multiply, you've got 3b times pi equals 4 pi. Obviously you can divide by pi and drop the pi. So then I'm solving for b. 3b equals 4, divide by 3, b is 4/3. So this would be 4x over 3 or 4/3 x. Any questions?
No.
All right, you have your worksheet for day 1 that you can work